Hi, third grade. I'm recording another math instructional video. This will upload on Wednesday, but it is my second one today because I'm trying something new right now. I noticed that when we're doing instructional videos, when we're doing read aloud, when we're doing our devotion, because I'm using my computer from school, sometimes the sound is cutting in and out, especially if I have a piece of paper that maybe I'm talking behind, or I'm looking down to read something, or I turn my head to read something or write something. So I ordered online a lapel mic, and it's this little microphone right here that clips onto your shirt. And so it came this evening in the mail. And so I was really excited to try it out. So we're going to see how the sound compares to other videos. I'm used to being in the front of the classroom, talking really loud so everybody can hear me, or talking really loud because I want the computer to pick me up. So I'm really hoping that I'm not going to shout and have this be too loud for you guys, but I hope this will also help the sound be consistent so that you can hear what's going on without it cutting in and out. So I am recording lesson 101, tables and schedules. Our objectives that we're going over are read and use schedules to solve elapsed time problems, use tables to solve problems, and use clocks to solve elapsed time problems. Tables are, a schedule is one type of a table. So a schedule is a specific table. And yesterday you saw a table in the extra credit for the investigation 10 on probability. That frequency table is another type of a table. But on your worksheet in your Learn at Home packet, this is what lesson 101 looks like. It says tables and schedules at the top, and it says tables can be used to organize information. And then they have a table here that shows the heights of major mountains. They have Mount Everest, Mount McKinley, which has actually been renamed Denali. It's in Alaska. Mount Kilimanjaro, the Matterhorn, Pikes Peak, and Mount Fuji. And then they also have another example of another table. A schedule is a list of events organized by time. So a table doesn't have to be organized in any specific way. It could be, by height or by weight or by frequency, like in the table from yesterday. But a schedule is a specific type of table that is organized in chronological order. It's by time. And then you have some questions at the bottom where you're going to be looking at these two charts to answer. It says refer to the table and the schedule above. Remember to write the units. Units is the label that you're using, and you need to pay extra special attention because if you look at the very first table with the heights of major mountains, it gives the height of Mount Everest in feet, 29,035 feet. And then also in meters, 8,850 meters. Some questions ask you for feet. Some questions ask you for meters. So you need to make sure you're reading very carefully through the problem and you're looking in the correct column. So if it says, hey, what is the difference in feet between these two mountains? Make sure that you are getting both mountains measurements in feet. And same thing if they're using it in meters. So we're going to go through a couple of different examples. Some of them that would be using time, some of them that would be using height. And we're going to use the mountain example for our first one. I'm going to quickly get our objectives off of the whiteboard. All right, so we're going to go over the example at the top of your reteaching worksheet. It says the Matterhorn is how many meters taller than Pikes Peak? So I'm going to grab my pen and I'm going to underline where it says meters so that I know I don't get anything confused right there. And it's saying, so it says Matterhorn and Pikes Peak are what I'm going to be looking at. So here is the Matterhorn. It's third from the bottom. And then Pikes Peak is second from the bottom. And it wants me to look in meters, so I'm going to be looking only in the right column at only those two mountains. And it says Matterhorn is taller than Pikes Peak. So I'm going to look up Matterhorn first. And on my chart, I look at Matterhorn, I look across to meters. I see that the Matterhorn is 478 meters high. And I'm going to make sure that I put my label in there right away. It is 4,478 M for meters. And then it says Pikes Peak. So I look across at my chart, Pikes Peak. And then if I look across, I can see it's 4,301 meters. So 4,301 meters. Now, if I'm finding the difference and I'm comparing something, remember that comparative problems are always going to be subtraction problems. So I've got my taller mountain on the top, my shorter mountain on the bottom. My units are not going to change, so I'm going to bring my label down right away so I don't forget it later. 8 minus 1 is 7. 7 minus 0 is 7. 4 minus 3 is 1. And 4 minus itself would be 0. So the difference is 177 meters. The Matterhorn is 177 meters taller than Pikes Peak. And that's an example of one I would use a table to help me solve a problem. Now we're going to do one with a schedule. Now we've seen things like this before. We've seen it in math. We've also seen schedules in handwriting, actually. You guys did a school schedule in handwriting where you had to write down and do some math. And we've seen a couple of these in our power-ups with elapsed time. So it's telling about a school day schedule for, we're not sure, could be one of you. If you left for school, you have to be pretty close to school if you're going to leave at 7:30 and get there by 8. It also looks like school gets out a little bit earlier than we do, but they probably don't have half-day Fridays. So it says what time this student gets up, what time they leave for school, when school starts, when they eat lunch, when school ends and they start to walk home, what time they get home and they get to eat their snack, when they start their homework, when they're done with their homework and they're able to play. So it says from 3:30 to 3:30 is when they start their homework. 5 o'clock is when they get to play. If I wanted to know how long it took them to do their homework each night, there's a couple of different strategies that I could use. One of the objectives for today said use a clock to solve elapsed time. So I could say 3:30 p.m. is when this student starts their homework. And they finish at 5 o'clock p.m. Post meridian, after the middle of the day. Now I could do addition or subtraction or Z method, but I want to make sure that we are using all of our objectives today. So I did remember before, I didn't remember to bring a spinner for investigation time, but I remembered to bring one of our mini clocks. I didn't bring the big Judy, but I brought a mini clock home. I could also just use the clock to help me figure out elapsed time. So I would want to start out with my clock. Remember, hour hand's the shorthand. So my hour hand would be on 3, and then 3:30 would be at 6. Would be pointing all the way down to 6. If you can see on these mini ones, or if you remember at school, it's got that teeny tiny 30 minutes. Now remember, the hour hand moves along with the minute hand, so it wouldn't be right at the 3 if it's not right at the o'clock. So if it's halfway between the o'clock and the next hour, then that means that my hour hand would actually be halfway between my 3 and my 4. So I've got 3:30 on my clock. This student then is able to relax and play at 5 o'clock. So how much homework does this student have? I'm going to start counting ahead. So if I move 1 hour ahead from 3:30, I went past the 12, so I've got to move the red hand, the hour hand. So that was 1 hour to 4:30. I'm not at my 5 o'clock yet, but they've been doing homework for 1 hour. I want to get all the way ahead to 5 o'clock. And another 30 minutes passed from 4:30 to 5 o'clock. So it was 1 hour from 3:30 to 4:30, and then another 30 minutes from 4:30 to 5 o'clock. So 1 hour plus 30 minutes would be how much time that had passed. 1 hour and a half, 1 hour and 30 minutes would be how long the student is spending on their homework. 1 hour and 30 minutes. Or I could say 1 hour, 30 minutes. So either this is a student who is older than 3rd grade, that they're doing 90 minutes of homework in the afternoon, or this is maybe a student who didn't use their time wisely in class when they had work time at the end of each subject. Maybe they were fooling around with their friends. Maybe they were busy fixing their behavior with a consequence. But hopefully this is not a 3rd grader that had an hour and a half of homework that afternoon. Now, I want to refresh our memory on the Z method too, because that's a newer method that parents might not be familiar with. So I want to do an example of an elapsed time problem without the clock. So let's say, what does it say here on our, so 7:30 is when this scholar leaves for school. 7:30 is when they leave for school. So 7:30 a.m. they leave for school, ante-meridian, before the middle of the day. And what time do they walk home? So they leave for home and then they walk home. 2:45 is when school ends and they start walking home. So I want to know the difference. How much time has passed between 7:30 a.m. and 2:45 p.m. post-meridian. Now I could, if I had a clock, I could do all of this with elapsed time and use that manipulative. I could do addition and subtraction, but when neither my beginning time nor my ending time end on an even hour, I prefer the Z method, and that's one that I didn't learn until I started teaching math. I didn't learn it when I was in elementary school, so your parents might not be familiar with that. I want to review that then. So instead of having it 7:30 to 2:45, whoa, I'm going to move 2:45 down here. That's my end time. And I'm going to make my Z. And I'm going to say, what's the nearest hour after 7:30? I want to get to an even hour. That would be 8 o'clock a.m. Now, what's the nearest hour before 2:45 p.m.? It's going to be 2 o'clock p.m. And now I'm going to figure out my chunks and then add them together. So from 7:30 a.m. to 8 o'clock a.m., how many minutes or hours have passed? From 7:30 a.m. to 8 a.m. is 30 minutes. And I'm going to come down here and do my minutes from 2 o'clock p.m. to 2:45 p.m. That was 45 minutes. Now I'm going to do my hours from 8 a.m. to 2 p.m. How much time has passed? So from 8 a.m. to noon is going to be 4 hours. And then at noon, remember, we start over with 1 because we're not using military time. So from noon to 2 p.m. is another 2 hours. So from 8 a.m. to 2 p.m., I've got 4 hours plus 2 hours is 6 hours. And then I've got 30 minutes and 45 minutes. So if I add 30 and 45, I need to know, is that going to be over 60? 0 plus 5 is 5. 3 plus 4 is 7. Remember how many minutes are an hour? In an hour, 60 minutes. So I have more than an hour's worth of minutes. I'm going to have to subtract 60 from that. So I'm going to have some more space over here. I'm going to do 75 minus 60. because that's my 1 hour. 5 minus 0 is 5. 7 minus 6 is 1. So I've got 1 hour and 15 minutes. And then I've got the 6 hours up here. So I'm going to do 6 hours plus 1 hour and 15 minutes How much time between walking to school and then walking home? 7 hours and 15 minutes. So I could write it digitally, or I could use labels. I could do 7 with the hour abbreviation and then 15 with a minute abbreviation. And that would be a review of Z method, which seems like it takes a lot longer. But once you get the hang of it, it's a really good strategy when neither your beginning time nor your ending time are on the even hour. If it's on the even hour, I usually like to just add or subtract or use a clock. But if neither one starts in an hour, for me, and just the way that my brain is, Z method is the easiest way, and I wish I would have known that when I was in elementary school. If that's not the easiest way for you, don't use that way. The cool thing, we've said it so many times in class, is that God made all of us differently. That includes all of us having different brains, and some brains work really well one way, some brains work really well another way. That's why there's so many different strategies in math, and use the one that works for you that helps you get to the answer. There are 4 problems on the bottom. Make sure you're checking your labels, because you don't want to accidentally, especially when you're talking about the mountain heights, you don't want to accidentally get meters and feet mixed up. And then at the bottom with the schedule, you don't want to get AM and PM mixed up. So there's one worksheet uploaded to the Google Classroom, and then tomorrow we're going to do lesson 102, tenths and hundredths on a number line. So this should be a little bit of a review because we've done number lines many times before. We're just taking it to the next decimal point over. So we'll see how well this microphone worked for this lesson.